Hi, my name is Abhishek. I'm joining UCSD as a master's student in the Department of Computer Science and Engineering. This video is a part of my teaching demo for my TE application. Today we are going to talk about hashing in machine learning. This lecture will be divided into two parts. One is we'll try to understand what is hashing. The other part is how can we integrate hashing into machine learning. The hashing is a core concept of computer science and cryptography, and we will continue that into using hashing in machine learning. So hashing is a mathematical function that takes an input of any size and convert it into a fixed length output. So it's like in a function where I give an input of variable length, the output I get is a fixed length output. We use hashing for different purposes. For example, storing passwords in our system or encrypting any data. Second, a couple of examples of popular hashing algorithms include a message digest or a secure hash algorithm, which is commonly known as SHA. A couple of properties about hashing includes, first, hashing has to be collision resistance. That means two different inputs cannot have the same output. If that's the case, it's called collision and we need to resolve that. Second, hashing is deterministic. Now, continuing on to the second part of this lecture, we are going to talk about what are the current methods that are used in machine learning to encode any text input. So generally, there are two types. One is we convert some words to indexes, or we convert words to their embeddings. For now, we are going to focus on the standard methods where we convert words to index, and these indexes are then used as a feature to the machine learning model. Here, we are not going to focus on embedding part of it, which is generally used in deep learning. A couple of examples of that includes fast text, flow, word2vec, but for now we are restricted to using hashing in machine learning just for the standard methods like, for example, naive Bayes, decision making, support vector machines. So currently the current methods, we need a long list of vocabularies along with indexes. So if in this universe we have maybe 10,000 words, then each word will have a separate index. So any input given by the user is mapped to a unique index for that word, and then a list of those words is combined together. We then go on to convert those words using something called one-hot embedding, in which where let's say I have a word M, and the index for the word M in our long list of vocabularies is 230. So I will be getting an array of size 1000 where all the values will be 0 except the index 230, which will be 1. Rest all values are 0, and this is clearly a waste of storage. So here comes the hashing. First, we need to understand how hashing is stored. Hashing, generally there are two ways we can store data collected using hashing. Is either is in the form of hash tables, which are nothing but a list of buckets where we store each unique hash. So the first bucket represents the number 1, number 2, and number 3. Let's say M, again the same word M, is when hashed gives an output of 231. Now this will be mapped to index number 2, the bucket number 2 in a hash table. Now let's go on to understand what is signed hash. So since each word has a semantic meaning which can be easily represented in terms of embeddings, but here it's slightly different. So for example, maybe a word like apple and a banana, since both are fruits, so they will be hashed to somewhere in a close range of hundreds. So they might end up falling into the same bucket. Now to resolve that, what we use is signed hash, where if in a sequence of words an apple appears first, so we assign it +1, and if again a word with the same hash value appears again, we assign it -1, so that the effective sum of both of these is 0, which nullifies the presence of both the words. Now let's understand hashing in machine learning with an example. So the movie was funny and hilarious. Now, this can be hashed into, the word V can be hashed into maybe 2, the movie can be hashed into 3, was can be hashed into 7, funny can be hashed into 5, and can be hashed into maybe 1, and hilarious will be again hashed into 5, because funny and hilarious are means the same, so we can they can both be stored in index number 5. So the final output that we'll be getting is, since we have 1, so 1 will go here. Then we have index number 2, so again 1 for index number 2. We have 3, so 3 for that. Now we don't have any index 4, so we'll write 0. And then since we have index number 5 and 6, but because funny and hilarious are nullified using this sign hash, so we'll again write 0. Then we don't have an index 6, so we'll write 0, and then we have 7. So now this becomes our feature vector for our machine learning model. So whereas as compared to the current methods, where this entire sentence will be stored in an array of size 1000, we are just storing it in the size of 7. Space, we save space and is more efficient than the current method. Thank you.